All right, hello folks. This is Rafat from Bari Science Lab, and sorry for the last interruption. We had to fix some technical difficulties. So let's get ahead and get started with some Math Olympiad problems. So to follow along, to help you follow along, I posted the problems online at Bari Science Lab and Bari Tutorial. So let's get started with the first problem. So what we have in the first problem, I hope you got all the problems. The first problem is a sequence problem. So what we have is that we're told that we have a circle, and the circle is divided into 12 sectors. Now, what is a sector, you may ask? Well, a sector is simply a part of the circle that's subtended by the central angle. For example, this is a sector. This is another sector. This is another sector. Now, what does the problem ask us? We're told that we have 12 sectors in total. And so now that you know what a sector looks like, this is what the problem is asking. We have a circle divided into 12 sectors. So we have a circle divided into 12 sectors. And we're told that these sectors, the measure of the central angle forms an arithmetic sequence between all these 12 sectors. So what does that mean? Well, for example, our arithmetic sequence is a sequence of the form a plus b, a plus 2b, all the way to a plus nb. N being the number of terms that this sequence has. Now that we know what an arithmetic sequence is, what would it look like in terms of a circle? Well, if we have a circle, an arithmetic sequence might look like the following: 10 degrees, 20 degrees, 30 degrees, all the way to however many sectors you have. So in this problem, we're told that we have 12 sectors, and we know that this is a circle, so all these sectors add up to 360 degrees. So what can we do to help us find the measure of the smallest sector? Well, we use the formula for the sum of an arithmetic sequence, which turns out to be the following. The sum of an arithmetic sequence can be found by the following formula. You take the number of terms and have it, and multiply that by the first term plus the last term. Now, in our case, we know that this will be equal to 360 because all the sectors of a circle add up to 360. So we're going to write equals 360. We also know the number of sectors we have, which is 12. We're going to write 12 over 2 times a1 times a equals 360. Now we know that a1 will simply be the the measure of the first angle. So let's call that 12 over 2 is 6. So let's call the degree measure of our first angle k. So that means since we have 12 sectors, the measure of our last angle will simply be k plus 12 minus 1, which is 11. Okay, but this is a common mistake. Why? Well, we don't know the common difference between the terms of this arithmetic sequence. So we can't just write 11. Instead, we have to write 11 times a variable. Let's call that r. So now we can simplify this to 6 times 2k plus 11r equals 360. So that means 2k plus 11r equals 60. Now, what are we actually solving for here? We're solving for the value of k. So to do so, we have to isolate k. Why are we solving for k, you may ask? Well, we want to know the measure of the smallest sector in our triangle, and the smallest sector will have a value of k. So let's go and do that. So we have 2k equals 60 minus 11r. So k is equal to 60 minus 11r over 2. Now, how can we go about solving this equation? We have two variables and only one equation. This isn't even a system of equations. So how can we solve this? Yes, I will explain hexadecimals in a minute after solving these 4 problems. How can we solve this? Well, we can solve this in a fairly smart method. We know that we're told that the value of all the sectors are integers. And for this value of k to be an integer, the numerator has to be divisible by 2. What does that mean? If the numerator has to be divisible by 2, 60 minus 11r has to be an even number. And for 60 minus 11r to be an even number, r needs to be even. Why does r need to be even? Well, because even times odd will give us an even number, and even minus even will give us an even number. And all even numbers are divisible by 2. So that's the approach we're going to be taking. Now let's go ahead and do that. To find the value of k, we're simply going to be substituting small values of r because we don't have to test that many values because 60 is a pretty small number already. So let's start by testing the first even value, r equals 2. If r equals 2, we have k is equal to 60 minus 11 times 2 over 2. This simplifies to the following. 60 minus 22 over 2 equals 30 minus 11, which is 19. But it turns out this is not the smallest you can go. Why? Well, because simply enough, 22, there's a multiple of 2 that's bigger than 2, and that will give you a smaller value for k. So let's try out 4. So let's try r equals 4. So that means 60 minus 11 times 4, 60 minus 44, which is 60 minus 22, 30 minus 22, which turns out to be 8. And that is our final answer. Why is it our final answer? Well, simply because if we try the next even value for r, which is 6, it's going to give us a negative number. And we know no geometric objects can have a negative measure. So let's go on to our next problem, which is a geometry question. So for our geometry question, we're going to need a ruler, such as this. So let me first draw out what we're told. So we have 2 circles externally tangent to one another. So this is circle 1, and this is circle 2. Let's name each of these circles. Let's give each of these circles a name, right? Let's call this circle A, and this circle B. Why not? Now we're told that we have the radius of circle A. The radius of circle A is 5, and the radius of circle B is 3. Okay, I'm going to draw in the radii later. We're also told that if we stretch segment AB to a certain point, the line externally tangent to both of these circles intersects that segment at a point C. So how can we draw that? Well, let's first extend this line segment AB. First, we have to draw it. Okay, so this is our line segment AB right here, and we're going to draw the line externally tangent to both of these circles right now. So okay, so let's pretend that this is the point of tangency, and this is the point of tangency for this. So this point we're told is C, point C. So now, what is the question that this problem is asking? Well, we're asked to find what is the measure of BC. So let's write that down. So this is what we're solving for. What is the measure of side BC? So how do we find that? Well, first of all, what we're going to be doing is drawing in the radii of circle A and B. So let's do that. We have the radii of circle A and the radii of circle B. We know the radius of circle A is 5. The radius of circle B is 3. So this is also 3. We know that the line connecting the center of the circle to the point of tangency is going to form a right angle. So let's draw that in right now. So we have this, and we also have this. So we know both of these are right angles. This is not good. Okay, so these are both right angles. What else do we know? Well, we know since these are both radii, this is also going to have 5. And similarly, this will also have a value of 3. Now what can we do to find this, BC? Well, let me first name some of these points. Let me give them some variable names. Let's call this M. Let's call this N. Now, the first thing we can do is notice that this is a irregular shape, right? So how can we find MN? Well, simply put, we can draw a line perpendicular to AN from point B as such. And by doing so, we create a rectangle. Because these are already two right angles, we have a third right angle, and so that makes this one a right angle. Now, what do we know about the problem? We know that this is 3, so this also has to be 3, meaning that since the whole length of AN is 5, this is going to be 5 minus 3, which is 2. Now we know that AB has a length of 8, and we know that let's call this, we don't need to call it anything. We know that this segment has a length of 2. So to find the length of this segment, what we have to do is simply use the Pythagorean theorem. We do, let's call this x, y. Actually, oh, this is the center of the circle. We don't need to call it anything. So we know that ax squared plus bx squared is equal to ab squared. So that means bx squared is equal to ab squared minus ax squared. And ab squared is simply 8 squared minus ax squared is simply 2 squared. So we're going to have 64 minus 4, which is 60, meaning that ax is going to be the square root of 60, which is the square root of 4 times the square root of 15, which is simply 2 root 15. So what does that mean? That means this length here, bx, is 2 root 15, meaning that mn is also 2 root 15, because remember, this is a rectangle. Now we have almost everything we need, but we still don't know what BC is. To find BC, all we need to find is MC, because this is a right angle, so we can use Pythagorean theorem after finding MC. But how can we find MC? Well, notice that these two triangles are similar. We have triangle C is congruent to triangle C by the reflexive property, and we also have these two right angles, right? So by angle-angle similarity, these two triangles are congruent. So what can we do? We can write that statement. We write the following similarity statement. Triangle CMB is similar to triangle CNA. Okay, so we've written the following similarity statement, and we can use that similarity statement to help us solve for BC. How can we do so? Well, we want to find CN, so we use that to our advantage. CN, let's call CMY. So CN is to CN as, let's just choose a random segment, BN is to AN. Right? Do we have BN? Yes. Do we have AN? Yes. So now, we know that CM, we just call that Y right now. Let me designate this space. We know that CM is going to be Y over CN. What is CN? CN is Y plus 2 root 15. So Y plus 2 root 15 is going to be equal to BM, which is 3, over AN, which is 5. So now we simply solve for Y. So 5Y equals 3Y plus 6 root 15. So subtracting 3Y from both sides, we get 2Y is equal to 6 root 15. So Y is equal to 3 root 15. So what does this mean? Well, since Y is equal to 3 root 15, we can replace Y by 3 root 15. And now we know the value of CN. We also know the value for BN. So we can simply find BC right now using the Pythagorean theorem. So we know that CM squared plus BM squared equals BC squared. We know that CM is going to be 3 root 15. So 3 root 15 squared plus BM is going to be 3 squared is equal to BC squared. So we have 3 root 15 squared is simply 9 times 15 plus 9 is equal to BC squared. Now, if you factor out 9, you get 9 times 16 is equal to BC squared. So BC is equal to the square root of 9 times 16, which is 4 times 3, which is 12. So that means BC is 12. And we have our answer. So BC is equal to 12. All right, so we've solved our second problem. So let's go ahead and solve the third problem. So if you're just joining in right now, you can find out the problems on Body Science Lab or Body Tutorials. So okay, so let's get ahead and get started with our third problem. So what does our third problem ask us? So this problem is it is pretty tricky. So it's an algebra problem, and we're told that a leap year. We know that a year is a leap year if and only if. So let's write that down. Leap year. So we're told that leap years are distinguishable because leap years are divisible by 4, but not 100. And also we're told that they're divisible by 400. So 400. So that's how you know if a year is a leap year. Is 2018 a leap year? You have to check these conditions to find out, but I'll tell you the short answer. No. So how do we get started? What is the actual question actually? So we're told that the 200th anniversary of Charles Dickens' birthday was February 7, 2012. So let's write that down. The 200th anniversary. So 200th anniversary on February 7, 2012. Now, Tuesday. So we're told that this date is Tuesday. So, what day of the week was Charles Dickens born? And you can just use this for your own birthday, right? When is your 200th anniversary? And you can backtrack using this problem solution. So how can we get started finding Charles Dickens' birthday, day of the week? Well, the first thing I do is first take a look at the problem. What are we told? So we know that a leap year is divisible by 4, but not 100. Is 2012 divisible by 4? Yes. Is it divisible by 100? No. So 2012 is indeed a leap year. So 2012 is a leap year. So that's the first progress we've made. 2012 is a leap year. Now, we know that 2012 was a Tuesday. Now, this might seem astonishing at first, and hard to understand at first, but every year, the day of the week changes. So for example, January 23rd, today, is a Wednesday, but come 2020, January 23rd will be a Thursday. Come 2021, January 23rd will be a Thursday. And the opposite thing happens when you go backwards. This year is 2019. If we backtrack to 2018, January 23rd will be a Tuesday instead of a Wednesday. And why is this? Well, it's simply because we're adding 365 days every single time to the day. So for example, let's say that today is a Wednesday. So let's give Wednesday a certain number. Let's call it 5. If I add 365 to 5, we'll have a different remainder when we divide it by 7. At 365 again, we'll have a different remainder once again. And that's why the day of the week changes even when you're on the same date every year. So how can we use this to our advantage? Well, we know that February 7, right? So 1 year, how much difference will 1 year make? Well, we know that if you go to 2011, February 7 will be Monday. Why? Well, because 365, the number of days in a year, mod 7, the number of days in a week, will be congruent to 1. Now, why is this so? Well, you can figure it out pretty quickly. When you divide 365 by 7, it'll give you a remainder of 1. Now, how can we use this to our advantage? Well, because this statement is true, that means every year when we go back, Tuesday will become a Monday, then a Sunday, then a Saturday, and so on and so forth. But what about leap years? Well, a leap year has 366 days. So 366 mod 7 is congruent to 2 because it's one more than 365. Right? So that means every leap year, you're actually going to go 2 days back. So for example, let's say you have 2013, right? So 2013 will be a Thursday. On 2013, February 7 will be a Thursday. But when you go back to 2012, you'll backtrack 2 days. So Wednesday, Tuesday, if that makes sense. So now we know that 365 mod 7 is congruent to 1. 366 mod 7 is congruent to 2. So we know how much February 7 will go back on a normal year and a leap year. So now we have to find how many leap years and normal years there are between 2012 and 200 years ago. So a leap year occurs every 4 years, right? So we're going to be doing, since a leap year occurs every 4 years, 200 divided by 4 will give us, okay, so this is number of days back in year and leap year. Okay, so that's what we found right here. So let's move on to step number 2, right? And that is how many years and leap years are there in the past 200 years? Well, to find the answer to that question, the first thing we do is 200 over 4, because we know there's a leap year every 4 years. So that gives us 50, right? But we have to be careful. Why is that? Well, simply because 19, what is it? If you go 200 years back, that'll give you 200 years will give you what? 200. That'll take you to 1812. So one mistake a lot of people make here at this stage is that they forget 1900 actually is not a leap year. Well, why is that? Because 1900, while it is divisible by 4, is divisible by 100. So it is not a leap year. Okay. What about right? So that's why 1900 is not a leap year. And instead of 50 leap years, we'll have 49. Now you're probably thinking 1900. What about 1800? Well, 1800 is divisible by 400. 1900 is not. Right? If you try that out, 1900 divided by 400. Right? 4 doesn't divide 9. So 19. But 4 also doesn't divide. 18 doesn't. Well, so let's move on. We know that there were 49 leap years in the past 200 years. So what about normal years? Well, if there are 49 leap years, the number of normal years will simply be 200 minus 49, which comes out to 151. So 49 leap years and 151 normal years. Okay, so now we know the number of normal years and the number of leap years, and we know how many days to backtrack for each of them. So let's use that to our advantage. So we have 49 leap years, so 49 times the remainder that each leap year gives us, and 151 times the remainder each normal year gives us. So now, what does that give us? 49 times 2, that's a simple 98, right? So 98 plus 151 is simply 100 plus so 249. So we have to backtrack 249 days. Now, that's a lot of days, and you don't want to do all that counting. So we simply take 249 mod 7. 249 mod 7 is congruent to, well, let's find out. 249 7. Well, this is going to give us what? 7.139. 7 times 5, 35. So 4. So that gives us a remainder of 4. So that means 249 modulo 7 is going to be 4. So what does that mean? That simply means we're going to backtrack 4 days starting from Tuesday. So Tuesday, before Tuesday is going to be Monday. Before Monday is going to be Sunday. For Sunday, Saturday. So we backtrack what? 1, 2, 3, one more time. Will give us Friday. So after backtracking 4 days, that means our final answer is going to be Friday. So let me write that down. Right. Okay, so that is our answer for this problem. So let's move on to question number 4. So let's move on to the last problem we're going to be solving today, which is once again a sequences and series problem. So if you're tuning in live right now, then just ask any questions you have in the comments, and we will address them. So, what does the fourth question ask us? The fourth question is asking us, what is the difference between the greatest and least iterative average of 1, 2, 3, 4, 5. Now, a lot of you folks out there may not know what an iterative average is. So let's go over that for a bit. Let's say we have, the numbers 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. An iterative average is taking these numbers, these 5 numbers in any order, and finding the average of them one by one. So let's say I take 1 and 2, right? I find the average of 1 and 2, gives me 3 over 2. I take that average, 3 over 2, and find the average of 3 over 2 and 3. Find that average, add that to 4. Find that average, add that to 5. Find that average. Repeat for however many terms you have. So that's what an iterative average is. So how can we apply that to this? How can we apply that to this problem? Well, the first thing you can do is generalize, right? An iterative average, no matter what way you arrange the terms, will look something like this. Let's say we take the following variables, right? A, B, C, D, E. Let's say we're working with these numbers. Well, the iterative average of these will be A plus B over 2 plus C over 2 plus D over 2 plus C over 2. Now, how can we simplify this? Well, and why would I want to simplify this? Well, because it would help me address how I can maximize and minimize this function right here. So all we have to do right here is find common denominators, right? So instead of C, we write 2C over 2. So this simplifies to A plus B plus 2C over 2 plus D. right? And this will simply become a plus b plus 2c over 4, right, over 2. So now we're going to make common denominator with the d. So we have 4d over 4. So now this will simply become a plus b plus 2c plus 4d over 8. So we've reduced all of this, right? Including this actually. So let me erase this and rewrite it. So we have a plus b plus 2c plus 4d over 8 plus c over 2. So now instead of e, I can write 80 over 8. So this will simply become a plus b plus 2c plus 4d plus 80. And once I multiply by 8 on numerator and denominator, I get the following: a plus b plus 2c plus 4d plus 80 over 16. So now it becomes really clear what we need to maximize and minimize to find the answer. To find the minimum, we need to make the smallest values 5, 4, 3, and 2. But to maximize our answer, we need to make E, D, and C the biggest values. So let's do that. So let's see, max and min. Okay, so let's go ahead and get started. The maximum is going to be 1 plus 2 plus 2 times 3 plus 4 times 4 plus 8 times 5, right? So divide all of this by 16. So now we're going to do the opposite with the large numbers early on. So 5 plus 4 plus 3, sorry, 2 times 3 plus 4 times 2 plus 8 times 1, which is just 8. So let's simplify this. We have 3 here, 6 here, 16 here, 40 here. That should give us 9, 25 plus 40 is 65 over 16. This is 9, 6, 8. 8 plus 8 is 16, 32 plus 9. Probably made a mistake right here. Let's see, 5 plus 4 is 9, plus 6 is 15, plus 8 is 23, plus 8 is 31. So this is actually 31 over 16. But careful, these are not the answers. Because first of all, how can you have two answers? And second of all, you're asking for the difference of the maximum and the minimum. So we simply do 65 over 16 minus 31 over 16, which gets us to 34 over 16, which if you simplify that, will give you 17 over 8 as your final answer. So folks, thank you for watching, and I will see you in the next video. Yes. Almost.